video, we will learn how to solve equations with variables on both sides of the equal sign. If you take a look at this equation, this looks different from any other equation we've seen so far because we have x values or x variables on either side of the equal sign. Our goal is to figure out what x equals that would make these two expressions equal to each other. So in this case, we have 8x minus 2 and we have 3x plus 3. So what would x have to be to keep these things equal? This is a lot harder to do in your head or by working backwards because we don't know what either side is supposed to equal. We just know that it's supposed to equal each other. So we could use trial and error and plug different things in for x and see what would work, but that could take a very long time because there are a lot of options for what x can be. They can be really anything. They don't always have to be whole numbers or integers, and so therefore solving that way is not recommended. So what we want to do here is our first step in solving these problems. Our number one step is to get all of the x terms, or whatever the variable is we're using, on one side of the equation. So how we're going to do that is we're going to either add or subtract the entire x term, one of them, from either side in order to move it or combine it onto the other side. Now, we can't simply say 8x and 3x equals 11x because they're on opposite sides of the equation. So we're not adding them together here. If we were, then the 3x would be on the other side already with a plus sign. But right now it's 8x minus 2 is equal to 3x plus 3. So what we need to do here is we need to be able to completely eliminate the 3x. I'm going to use the smaller of the two. I want to completely eliminate the 3x from this right side of the equation. If I want to completely be able to cross out this whole 3x term, I'm going to have to subtract the entire 3x term from the right-hand side and from the left-hand side of the equation. We have never done this before where we subtract the term with the x. Usually we divide by 3 here because we're trying to find x. But our goal right now is to move this entire expression, 3x, to the other side to combine it with the 8x. So the reason we're subtracting is because in order to get rid of it on the right-hand side, I have to get 0. So 3x minus 3x is 0. So now there's no more 3x on this right-hand side. There's just that plus 3 left by itself. And then on the other side, 8x minus 3x is 5x, and the minus 2 remains the same. Once you get past that first step there, that's the trickiest step. Once you get past that step, the rest of the problem remains the same as what we've done in the past. It should just now look like a regular two-step equation where we add 2 to cancel out the minus 2 and divide by 5 to cancel out the 5 to get x equals 1. So remember, first step is to get all of the x variables all on one side. So that is our new step, and that is a little bit different than what we've done in the past. Let's try this one. We have 8 minus 9t equals t minus 12. Again, our first goal is to get both of the t terms on the same side of the equation. Now, in this example, instead of subtracting t, like I did in the last one, because this is a 1t, and that is smaller than 9t, but since this 9t has the subtraction sign in front of it, I'm actually going to try to cancel or cross out the minus 9t by adding 9t. This will avoid any negatives that I would get if I ended up subtracting 1t from the 9t. So now we have 8 equals 1t plus 9t, which is 10t, minus 12, and then add 12, giving us 20 equals 10t, and divide both sides by 10, giving us 2 equals t. And for our final example, we have a negative 10m plus 7 equals negative 7m minus 11. In this case, we need to be able to completely cross out either the negative 10m or the negative 7m. And to do that, we're going to have to add one of them to both sides. You could add the 7m to both sides, or you can add the 10m to both sides. In this problem, I'm going to choose to add the 10m because when I add 10 to a negative 7, that's going to make a positive 3. If I added 7 to a negative 10, I'm going to be left with a negative 3, which isn't wrong, but if I can avoid negatives, I'm going to. So now we have 7 equals 3m minus 11. We now add 11 to get 18 equals 3m. And dividing both sides by 3 gives us m equals 6. Take a few minutes to try to solve these two equations and see if you can get the answers that are shown here. For this first one, I would subtract 4t from both sides to be able to cross out the 4t on the right-hand side. And that would give me a 1t plus 7 equals a negative 9. Make sure you bring that minus sign down with the 9. And then if I subtract 7, t equals a negative 16. In the second example, I'm going to add the 1x to both sides so that a negative x and a plus x cancel out, giving me 3x plus 16 equals negative 5. If I subtract 16 from a negative 5, I get 3x equals a negative 21. And if I divide that by 3, I get negative 7. Here are two more for you to try.